So this laboratory is about power control, and we're going to do it in two parts. There's an AC section and then there's a DC section using PWM, which I'll do in another video. In the AC section we're going to use the SCR. So SCR is a silicon controlled rectifier. It looks very similar to a transistor. There's three terminals, but we have the anode, the cathode, and the gate in the SCR. The SCR has a unique rectifier type characteristic. In the reverse direction, it looks just like a regular rectifier or diode. But in the forward direction, instead of being a regular diode, we can actually put a signal on the gate and turn on the rectifier from the off condition. So normally the SCR is off in the forward condition unless you exceed it breakover voltage, but normally we treat it as off. But we're going to control the gate through this circuitry here to turn on the SCR. Now this circuit is very similar to the one that's in the Webb and Greshok book, so you'll see a copy of that. So I'm going to start out in the off condition. The green signal we see on the scope is of course the AC supply from Edison. The yellow, which is currently 0, is the voltage across the lamp. One useful thing to keep in mind is that if the green signal is represented by this sine wave and the yellow signal is represented by the lamp, then the remaining signal, or the difference in those two, must be across the SCR. Because in the main circuit, we simply have the lamp and the SCR in the path of the AC signal. This circuitry over here is really in parallel, and we don't need to pay a lot of attention to it in terms of the signal we see on the scope. Alright, so keep in mind the AC signal, which we see as the green. So we're going to turn on the SCR, at least gate it a little bit. Now I've set the scope up so that I have 3 divisions for a half cycle. A full cycle of AC is 60 cycles, of course, 60 hertz, which is 16.66 milliseconds. So that means this is 8.3 milliseconds. Now I'm recording a value of around 2 milliseconds there on the screen. And the voltage we're measuring, this is divided by 10, so that's 27.6 volts RMS, and that comes from that little slice of the yellow signal. Now remember, that is across the lamp, so the difference between that and the green is the AC, the voltage across the SCR. The SCR is in the blocking mode on the reverse bias, so that takes the full voltage. It takes most of the forward voltage except when we trigger it on. So we'll increase it to 30 degrees, which is 1/3 of that half cycle, and we'll look at the voltage there. So adjusting a little bit, it's a little hard to tell, but the light bulb's getting a little brighter. So that's around 2.6 milliseconds. We've gone up to 35.9. The lamp's gotten a little brighter, so we'll increase it to halfway, which we'll know is 90 degrees on the signal. We see a little spike on the SCR voltage, or the lamp voltage. That's from the switching. So now we're at 56.3 volts RMS. We've got about half of the signal. Remember, that's the SCR, or the lamp signal, and the SCR is taking the remaining portion that adds up to the green. So I'll increase it now to 60 hertz, 60 degrees of signal measurement. We're now at 65.6 volts RMS, and the voltage across the RMS is the remaining part of the signal plus the reverse. And then finally we'll do a little bit more, maybe halfway to the 180 degrees from where we were. Now we're at 67.8 volts on there, and the lamp is quite bright, and then we'll continue all the way to maximum signal. And that's actually half the signal, right? Because the SCR only works in the forward direction. If we zoom in a little bit, you'll notice that the SCR takes a little voltage to turn on. This is 50 volts per division, and it's somewhere around 10 to 15 volts before it gets triggered on, right? But once it's on, the voltage appears across the lamp. Like I said, the lamp is represented by the yellow signal, and then the green would be, the difference between the green and the yellow is the SCR. So the SCR is blocking all of this green up till it goes to the yellow signal. All right, by the way, the final voltage there is 66.6 RMS. Since this is half the signal, double 66 and we get 132. So we're a little off from our 120 volts our RMS signal. The actual supply there, if I turn on the green signal, is 120.5. So a little bit higher RMS equivalent. So that's the SCR operation, simply controlling the phase of the trigger on the SCR. So this is pretty effective with light bulbs, as we'll see with the Triac also. So for the Triac circuit, I'm going to use a conventional incandescent light dimmer that you can buy from Home Depot or any home improvement store. I'm going to feed the voltage out of this dimmer circuit to this outlet strip so I can run the lamp and also view the voltage on the scope. I have the voltage measured over here for the RMS value. Okay, again, it'll be divided by 10. There's actually two options for the Triac circuit. You can make a Triac, or at least a circuit that behaves like a Triac, by putting a bridge rectifier in front of the SCR circuit. Since the SCR only works in the forward direction, then that means that if I make the voltage into it from the AC rectified, then I will have positive values and I can trigger on my SCR. A Triac actually uses two SCRs in a parallel back-to-back kind of operation. Okay, so we start with the lamp off. Green, there's no signal to the lamp, or 0 volts, and that's what's represented over here on the meter. This meter is reading 1/10 of the RMS voltage. All right, so as before, I'm going to adjust this so that we get about 30 degrees of adjustment on each point. So that's 30 degrees, or 1/3 of the positive sine wave. But now we see the second half, or the opposite polarity. The voltage that is being measured here is 55.7 volts. So that is the true RMS, sorry, 55.7 volts. There's the lamp, right, and its brightness. I'll go to 90 degrees or of adjustment capability. So we get halfway there, and we see about 86.5 volts. The lamp's getting brighter, If I continue to adjust to 2/3 of the signal, so now I've got 2/3 positive and negative, I'm at 109.8. Remember, RMS value is related to peak value, so even though this is only 2/3 of the signal, this contributes less to the RMS. And then finally we'll go to maximum, and we'll see 119.8 volts, which is equivalent on the lamp. Pretty bright. Again, you can see on the Triac, the area, you can see where it is not, it takes a little bit of voltage to turn on, right? And also in the positive and negative directions. Very similar to the SCR. This is 50 volts per division, so somewhere around just under 50 volts it turns on for that adjustment. And we can adjust wherever we want. Okay, that's the SCR and Triac circuits. I'll give you some scope screens so you can look at those.